let's talk about the electrical component known as the resistor. So, what is a resistor? What is its application in everyday electronics? And more importantly, how do we use it? Let's break down the concept of a resistor in a simplified manner so that we can build a solid learning foundation. The resistor is one of many electrical components which is classified as a passive component. They are passive in the sense that they work with the signal that is passed to them without introducing any net energy into the circuit. Therefore, they do not require an external power source, but instead rely solely on the available energy within that connected circuit. They can also be further classified as linear devices, where the output signal is directly proportional to the input signal. This can be seen from Ohm's law, which states that the voltage across a conducting material is directly proportional to the current flowing through that material, V equals IR or I equals V over R. From this, we observe that if we increase the resistance, we then decrease the current. The resistor, as its name implies, will resist something, and that something is current. The resistor's value, or in other words, the strength of resistance, is measured in the units known as ohms. Let's take a quick look at this circuit here. We have a power source of 10 volts connected to a 5 kilo ohm resistor. Let's draw the current to be flowing clockwise, and to find the current, we'll just rearrange the formula from Ohm's law to get I equals V over R. This means that the current I is equal to 10 over 5, which is 2 milliamps. And if we increase the resistor value to something bigger, such as 10 kilo ohms, then the current decreases down to 1 milliamp. So what we are seeing here is that the resistor can be used almost like a valve to regulate current flow, and that is basically one of the main applications for it, to reduce or limit current. This is very important for driving many electronic circuitries or devices. There are many device components out there that require a controlled amount of current in order to function properly, and so a resistor makes that possible. One basic example is an LED. If you put too much current through it, then it will burn out and become useless. So, we need a limiting resistor in order to protect it. Interestingly, the current regulated by the resistor not only protects the LED, but also determines its brightness. One question that you might be thinking is, where does that resisted current go? Even in the first example, we further reduced the current from 2 milliamps to 1 milliamp. So what is the resistor doing with all that subtracted energy? They aren't storage devices, and so we know that the energy isn't getting accumulated within. We also know that energy can't just disappear. The answer is familiar to us all, but let's have fun exploring it together in our next video. Thank you for watching our video on Break It Down to Me. We hope you found it valuable. Be sure to explore our growing library of videos covering STEM, philosophy, critical thinking, and more as they become available. Subscribe and hit the bell icon to stay updated. Your support through likes, shares, and comments helps us reach more viewers like you. See you in the next video.